we start? Start? Okay.
Good evening, everyone. I welcome you to the Physics Deep Thought of Mimamsa 2026. My name is Shubhra.
And my name is Pooja. We are the podium coordinators for the Physics Deep Thought.
We'd first like to introduce the judges for this round, Professor Sunil Mukhi and Professor Bhas Bapat. Professor Mukhi is a Raja Ramanna chair. His work concerns quantum field theory, gravitation, black holes, string theory, and quantum entanglement. He is the receiver of the S.S. Bhatnagar Award and the J.C. Bose Fellowship.
Professor Bapat is a faculty member in the IISER Pune Physics Department. He works on atomic collisions, molecular fragmentation, and Auger electron spectroscopy. He was part of a team that built an ion spectrometer on board the Aditya L1 mission. We request our judges to pick a chit and determine the first team to answer the question. We'll proceed clockwise from them.
So the first team is going to be IIT Delhi.
So the team order is IIT Delhi, IISc, IIT Madras, and IISER Bhopal. We will now begin with the physics deep thought. The questions are Oppenheimer on Bhang, RIP drill, happy happy joy joy, rolling in the deep. IIT Delhi, please choose your question.
RIP drill.
RIP drill. Tired of evil Lord Mia notorious acts, Dr. Upper Mia tries to create a feet-tickling gun in his lab and comes up with a prototype setup in a vacuum on an aluminum sheet. Dr. Upper Mia keeps a small magnet called floater kept upright. Dr. Uppermaya expected the two magnets to stick to each other, but that did not happen. Instead, for a sufficiently high omega, the system achieves a new stable equilibrium state. Help Dr. Uppermaya figure out this system and answer the following questions. Given that the force between two static magnetic dipoles scales as 1 by r to the power 4. Question 1. Describe the equilibrium state. Give a mechanical explanation about how the system evolves to the equilibrium position. Considering that initially there is a net attraction between the two magnets, explain why an equilibrium exists. What are the competing forces on the floater? The floater is free to move in any direction. Omega is very high, of the order 10 raised to the power 3 radian per second. Question 2. Plot the graph for the time average potential energy of the system. The distance between the rotor and the floater. Argue what the form of the mathematical expression should be to achieve the equilibrium state, and give an explanation for your answer. Note, you need not provide the exact constants in the expression, but put a constraint on the expression. Question 3. Give the qualitative relation between the mass of the floater and the minimum omega required for the equilibrium to be achieved. Question 4. On the same graph, draw a qualitative trend observed for the time average potential energy V by S distant curve for the system for different values of omega. Question 5. How will the theta change if gamma is increased or decreased given that the same equilibrium position is maintained? Assumption. All forces can be approximated as power laws or linear combinations of power laws. The time average potential changes monotonically with omega. Ignore gravity, ignore relativistic effects, assume short dipoles. Ignore heating effects with the magnets. Assume that the magnetic fields of the rotor and the floater are much greater than the magnetic field of any other secondary source. The magnets never come close enough to touch each other. Assume no friction in the drill. Participants, do you have any doubts about the questions?
What exactly do you mean by floater? Like it's not in contact with the aluminum plate at all?
Question making team.
Initially, it is kept on the aluminum plate. In the equilibrium state, it is not.
Okay.
Yeah, it's no longer on the aluminum plate.
Any other doubts? Teams of 15 minutes for thinking start now.
Yeah, Team IIT Madras.
Stable condition, is the floater also revolving, like rotating like this when the rotor is moving?
It can.
It's not fixed. Yeah, it's done.
10 minutes remaining.
Yes.
Why exactly have you given an aluminium plate?
That is for you to figure out. Yeah.
Yeah, but there's a reason you have specifically mentioned aluminum plate question mark versus a normal plate.
Yeah, it's mentioned in the question.
5 minutes remaining. 1 minute remaining. Thirty seconds remaining. Teams, your time is over. IIT Delhi, you have 5 minutes to present your answer. Your time starts now.
Q1 का equilibrium state होगा. So for the question 1 in the equilibrium state, we can argue by symmetry that basically if the floater is at any suppose the floater is at any angle theta and it's non-rotating. So first I'll describe the equilibrium state. Equilibrium state will be that the floater will rotate about the axis of the drill with the same omega as the rotor. The floater will rotate with the same omega as the rotor in the same direction. And this will be true because if say it's not rotating, then by symmetry argument, if you take the mirror image about the drill line, because the rotor is it's rotating about that axis, both left and right side are equivalent, so being biased to one side is impossible by symmetry argument, and hence it's either staying stationary, which won't be possible here because it has a non-zero torque there, so hence it has to be rotating at the same angle and it has to be the same angular velocity as the rotor, again by the symmetry argument. So yeah, so that's the equilibrium state. And as for the competing forces,
So the floater is balanced between the two, one virtual floater that we have created by creating using the concept of magnetic imaging. So we are considering an image of the floater with respect to the aluminum plate, and so we are effectively balancing the two attractive forces by the rotor and the virtual floater. The two attractive forces of the two of their attractive forces will balance, and hence equilibrium state will be achieved.
For question 3, we claim that the torque delivered due to magnetism, as seen in a lot of examples, is not dependent on the mass, and it is also equal to I alpha. So by dimensional analysis, we see that like this is the dimensions for torque, and the factors which can affect it are like Kp, the product Kp, which signifies the magnetic properties, ml to the 4t minus 2, the distance d between those two, and the omega of the rotor, t inverse. Solving by dimensional analysis, we get that it is independent of omega, and therefore mass will stay constant. Sorry, omega will be independent of mass. Omega will be independent of mass. Minimum omega.
therefore what? Omega, omega is proportional to 1 by m. Omega is proportional to 1 by m. So I alpha is equal to torque, and the torque comes out to be independent of mass because of dimensional analysis, and hence I is proportional to m, and hence alpha is proportional to 1 by m, and hence omega is proportional to 1 by m. And as for question 2, the system can be broken down to basically, since it's rotating at extremely high angular velocity omega, the north pole will trace out this trajectory, south pole will trace out this trajectory. It will be equivalent to simply a dipole. We can approximate it to be simply a dipole pointing upwards, whose magnitude will depend on sine of gamma. And similarly, the bottom one will also become a dipole, amplitude being cos theta. And the potential energy between them will be proportional to 1 by r cube, because in question we are given force between two dipoles proportional to 1 by r4, and hence potential energy will be 1 by r cube. So that's the answer for question 2. Actually, we have to plot it. So yeah, 1 by r cube. So basically is this. R and B. And he'll explain the angle relation for question 5.
So now we look at question 5.
1 minute remaining.
So we have drawn a simple diagram highlighting all the angles. The rotor is at gamma with respect to the horizontal, and the floater we have assumed to be at theta. So using this relation, which relates the angle of the field lines for any general theta, here our theta is 90 plus gamma. Not theta, alpha is 90 plus gamma. So tan phi, which is this angle, the line joining center of this magnet to this magnet, is twice the tan of the angle alpha. We know
30
that 90
seconds
minus phi is
remaining.
equal to theta. So using this, we can plot a variation of the curves of gamma and theta. Qualitatively, at small gamma, theta will be 0. It will increase, reach a peak, and then it will start to decrease as gamma tends to 90.
Question 4, this is our answer. For question 4, we know that as d increases, p will decrease, and then for
Time's up. IISc, you have 3 minutes to present your answer. Your time starts now.
Hello. So first I'm going to explain question 5. Okay. So how will theta change if gamma is increase or decrease? So if gamma is going to increase, my claim is theta is going to increase as well. And it's the simple logic is if gamma is going to increase and theta is not going to change or increase, then the attraction between the lower pole, which appears to be the south pole, of the rotor magnet and the floater magnet, attraction will increase, and the effect of omega will also decrease due to increasing gamma, due to which the equilibrium state won't be achieved and there would be an attraction upward. So to counter that, for gamma increase, theta should also be increased and vice versa.
Okay, all I'm saying here is the repulsive force. If it is above the form 1 by r to the n, then n will have to be greater than 4, and this is in line with the. Yeah, this is because for small r, the repulsive force is greater than the attractive force. So r to the power n will have to be. So 1 by r to the power n will have to be greater.
And we argue that the system will be in equilibrium, because while this thing is roughly getting attracted by the system, the equilibrium state that we are arguing is similar to the one that has been argued earlier, that this thing is effectively in line with it and rotating at this same angular speed. We are saying that the equilibrium exists because the induced currents due to the changing magnetic fields, the current induced in the aluminum sheet is going to produce a magnetic field that's going to allow this to effectively allow this to stay stable in the air and not just fly upwards towards the rotor magnet.
One minute remaining.
I mean, so if the for the fourth question, for the third question, the qualitative relation between the mass of the floater and the omega. So if we have seen that attraction one in the fifth question, the magnetic force versus the torque is. If I increase my mass, and if I don't change, say my omega or my omega is increased, my torque is basically going to increase. But since I am not changing my magnetic force or the distance between them, so that would effectively mean I am disturbing it for my equilibrium position, but I don't have to disturb my equilibrium position. So my claim is if my mass is going to increase, my omega is going to decrease and vice versa. That's my explanation for the fourth part.
Time's up. IIT Madras, you have 2 minutes to present your answer. Your time starts now.
So in the third question, what we get is as we increase the mass, the minimum that we require will decrease. So uh, in the fifth question,
Yeah, like in third question, like as ideally pointed, like the omega is like proportional to 1 by m. This can also be proven by like conserving the angular momentum about the the fixed point of the floater. Like as all the forces are passing through that point, we can conserve the angular momentum, and from that omega will be proportional to
1
1 by
minute
m.
remaining.
And for fourth question, as the omega increases, this the graph shifts towards right, and it's inversely proportional to the distance. And
For the second question, we can obtain the potential term by k into p vector dot r vector divided by r cube. So sorry, d. So it will depend on the distance vector with this formula like kp cos the gamma
30
minus theta by
seconds.
d square. So if we draw the graph of time average potential with distance, we'll have an inverse square law. So this graph comes which is similar to this due to same equations.
and for the first question, like as like we know that there's no attraction between the two magnets. So what it is, like the magnetic force is acting as a centripetal force for for the like rotation of that floater. So it won't attract the.
Time's up. IISER Bhopal, you have 2 minutes to present your answer. Your time starts now.
For question number two, the graph if for a specific omega it will look something like this, because potential energy will be due to the dipole, and therefore it will be proportional to k cos theta plus some other power series expansion, or plus other
1 minute
cos-
remaining.
cos square theta and cos cube theta upon r square plus other terms. This will be the dominating form. This is the dominating term. Therefore, the graph will look something like this. And for different omegas, omega 1, omega 2, omega 1, the graph will look something like this.
When the angle gamma will increase, the resultant force of the attraction and repulsion will
30
shift
seconds.
towards equilibrium, will shift towards down, so theta will also decrease, and when the gamma will decrease, the equilibrium force will shift towards upwards, and the theta will increase.
Time's up. Judges, do you have any questions for the teams? No questions? Okay.
IISc team, what is that circle you have drawn in the plate there? The direction of current in the aluminum plate. Okay.
I now request a member of the question making team.
Clarifications by the QMCs as well. IIT Delhi, can you please tell me what is the specific symmetry argument that you guys were talking about?
Yeah, so we use symmetry argument to explain the initial equilibrium condition. So first of all, if it is to have an angle theta to the initial to the line of the drill, then if it's not rotating, then basically your drill is rotating in all directions, right? So if it's in a particular angle theta, you just take the mirror image to the other side. These both should be equivalent. Like you can't have a bias in a one direction. It doesn't make sense because it covers all the angles when the rotor is rotating. So that is eliminated out. So it has to be rotating. And if it's rotating, we argue that both the angular velocities also have to be same, and that is again by your symmetry argument. And the two balancing forces we have shown by magnetic imaging.
So what are the two balancing forces? You wrote something, but I didn't understand what you said.
Yeah, so because we have an aluminium sheet there, so basically we use the concept of magnetic images. So your rotor's mirror image will be like effectively you can remove the aluminium plate and have just a rotor image of the rotor with respect to the aluminium plate as the mirror, and those are the two forces that will be balancing your floater. The force due to
The floater will also have a mirror image, right?
Yeah, floater will also have.
What about that then?
Could you clarify if you said a rotor or floater?
Both. I mean, if you are saying that one can be analyzed by a mirror image, the other one should also have a corresponding image, right?
It will.
And then how does your argument go through?
And we've chosen to approximate the effects of it as negligible. We have only considered the interaction between the rotor and floater with its magnetic image. But it will have a magnetic image as well.
Like, because the floater is much closer to the aluminium plate than the rotor, so therefore I think the approximation.
Therefore, what if it is closer to the plate?
Because it is closer and the magnetic force will depend upon the distance, we have chosen to only consider the floater and floater's mirror image interaction. There will be interaction between the rotor's mirror image and the floater as well, but because the distance is much larger, we have chosen to neglect that term in our calculation as the effects will be much smaller.
Team IISc Bangalore, could you please explain your answer to question 3?
Our explanation is basically the torque term due to the omega. That also the term also has the factor of mass of the floater. So if you were to increase the mass, and if somehow the omega is not changing or increase, for instance, then your torque is going to naturally increase. But since we have not changed either the distance nor the orientation, the magnetic force is going to remain the same. So the equilibrium state is changed. Basically, it will not remain in equilibrium, and that will lead to some displacement. So to counter that, the omega must decrease so that the torque remains the same. Basically, it's kind of an inverse proportionality. The omega per equilibrium.
IIT Madras. So for question 1, you have mentioned there being a centripetal force. Centripetal on what object and from where?
On the floater, like it has like floater and rotor has the same angular velocity. So whatever the magnetic force the floater is experiencing, it is acting as a like centripetal force like for its rotation. Like if we see like a gravitation example, like gravity acts as a centripetal force and they don't like attract, like collide with each other. So that's what I think we believe that that's what will be the case here, like of not colliding of the, like that's why these both magnets are not colliding with each other
The centripetal force is on the floater.
on the floater.
Okay.
Yeah.
Team IISER Bhopal, could you please clarify your answer to question 2?
Okay, for question 2, basically the time average potential as distance increases, the time average potential will decrease because it is proportional to k cos theta by r cube. Also, the equilibrium, the distance between the plates for equilibrium, for the stable equilibrium, which is observed in this, will, if omega decreases, the distance will also decrease between the plates for equilibrium, for the system to achieve equilibrium. Basically, so those dotted lines are basically the d's at which the system is getting the distance between the floater and the rotor, where they are getting near the getting equilibrium at equilibrium point. So as omega decreases, that d decreases. So basically that is shown in
For your figure in question 2's answer, what is the y-axis?
in the question number 2 y-axis, it is time average potential energy.
Okay. Thank you.
I have a question for ISC. You said that the repulsive force should have an index greater than 4. Can you tell us how you argued that out?
I'm saying that the dominant index for small radius must be like greater than 4. So the point is we can write it as a power series, and we know that as r is smaller, for a larger r, essentially you have like 1 by r to the n and you've got 1 by r to the m. You're comparing that. So you're essentially comparing r to the power like m minus n. So for smaller r, if your n is greater, that term will be bigger. Like I've cross multiplied essentially. So
What are you comparing again? Just say.
comparing the 1 by I'm trying to guess what force it might be.
Okay.
So that is why I'm saying that the repulsive force, that is some 1 by r to the power n, say,
Yes.
plus a higher power.
Yes.
More negative powers, and then I'm comparing the I'm saying the most dominant term will be the one with the least power. So, and I'm comparing that to 4. That is
Comparing it to what? I didn't understand.
1 by r to the power 4.
4. Okay.
Yeah.
Okay.
Like if I'm comparing 1 by r to the n to 1 by r to the power 4. That's it.
But where do you get the 4 from?
That is given as the attractive force. So we know that the repulsive force must at some point become greater than the attractive force. That is it.
Force 1 by r.
Can you please repeat why it has to be greater than 4? Like why, when comparing, why n has to be greater than the given 4?
See, if n was less than 4, then the problem is if you reduce the distance to a very small, the attractive force is going to dominate since the magnetic pole is given, and then it would just attract. And since it never touches, it is given in the assumption. So we need the repulsive force to dominate for a very small distance, such that for a very large distance, attractive force dominate, and for a very small distance, the repulsive force is going to dominate. So there will be an equilibrium state in the middle. That's all.
Question making team, please explain the answer.
Hello. Yeah. So we have this setup, and this angle is gamma, and we have the aluminum plate here with the floater with some angle theta. So before we approach this, we can look at a simpler situation where we have a rotor with gamma equal to 0 and the floater with, well, it's horizontal. So, and there is no aluminum plate, it's all in free space. So now what happens is, say initially it is repulsive and they have a distance, my bad. They have a distance d between them. So this floater will get repelled and it will go down by a distance delta 1. And by that time this rotor rotates and it starts attracting the floater. So you can see here, so now this will be like this. D plus delta 1, and now they're attracting. So floater will get attracted again, but because this distance has increased, the attraction won't be as strong as the repulsion. Hence, it will come up by a distance delta 2, which is smaller than delta 1. So you have a net drift away from the rotor. So this is basically called polarity free magnetic repulsion. So when you have this setup, this magnet is spinning, the other one will drift away. So now here what you do is you take components, one in the horizontal plane for both of these and in vertical planes. Now you can see it in the image that these components are always attracting. So there's a attractive force scaling by 1 by r to the power 4. And these two components, they behave like this setup. And this floater, the omega of the floater is very, very small compared to omega of the rotor because of the aluminum sheet, which generates eddy currents, which generates its own magnetic field, which opposes its rotation. So the floater will rotate at a very small omega, and we can essentially ignore that. So you will have this repulsive force and this attractive force. And then because they are initially attracting, this will go up, but there is also this repulsive force, and because of that it will achieve a stable equilibrium somewhere with small oscillations, and it will be persisting with a very small omega. Yeah, that's for the first part. Second part would be, so you have a potential energy which is minus a by r to the power 4 plus b by r to the power n. So you can say that this n,
a by r to the power 3.
should be 3. N is strictly greater than 3 for there to be a stable equilibrium. So you will have a curve like this. Here you will have a stable equilibrium. Now the third question is, how does the mass and the minimum omega required relate? So what we see here is that because this is spinning really fast, this takes some time to move, and therefore as you increase the mass, you can lower the omega such that this particular system still holds. So if you increase the mass of the floater, you can decrease the minimum omega required for this equilibrium to achieve. Fourth question was to plot multiple plot average potential for multiple omegas. So this is for say omega 1. It is given in the assumptions that this potential is a monotonic function of omega, and if you take omega to infinity, you can see that this term should go away, because this is spinning really fast, so this distance travel would essentially go to 0. Hence, this is a monotonically decreasing function of omega, and from that you can deduce that the curve for an increased omega should look like this, with the equilibrium position having even lower potential energy, and it should be closer to the rotor. Now, next question was the dependence of theta on gamma. So, yeah, here, if you increase your gamma and your equilibrium position stays the same, so it's basically increasing the vertical component. So, because you need to keep your equilibrium position constant, you need to compensate by decreasing the force in the vertical direction, which is basically it'll increase the theta. So as gamma increases, your theta also increases, and vice versa. That's it.
Teams, do you still have any doubts? IISc?
Like, what is the like? I didn't understand what the repulsive force is over here. Is yeah.
Okay, so you have this, I'm taking you back to this simple example. So you have this rotor, very high omega, and there's a floater, free space. There is an aluminum sheet, there's no constraint. So there's some distance d between these two, and say initially they're repelling. So while it spins and it's repelling, this will go down by some delta 1. Now, once it starts to attract, this floater will go up by a distance delta 2, which will be less than delta 1, because it's now farther away, so the magnetic force will decrease. Right. So there is a net drift in away from the rotor. That is your averaged repulsive force.
Okay.
Any other doubts? Yeah. Yes.
So potential energy is 1 by r cube, right? Yeah. So in the question, omega is given very, very high. So in the solution, they ignored the second term of 1 by r cube power 4. So the answer for part 2 becomes that potential energy proportional to 1 by r cube, right? Because we are ignoring the second term as omega is very high.
No, but if you ignore that part, you will not get a stable equilibrium.
Acha, okay.
Any other clarifications?
Let's begin with the next question. IISc, please choose your question.
Oppenheimer on Bhang.
Oppenheimer on Bhang. Srivatsa and Agastya are nuclear weapon scientists who study weapon yields. They walk into a bar and start arguing about nuclear weapon fireballs. The barmaid Ria, a Soviet spy, overhears the conversation. Being a barmaid, she has obviously studied nuclear physics and gathers that the two are talking about a phenomenon known as the double flash. However, both Srivatsa and Agastya pass out before she can learn why it happens. Help Priya figure out the details of the phenomenon so she can help the USSR achieve communist world domination. Looking through a briefcase left behind by Srivatsa and Agastya, she finds the following graph of the luminosity versus time for the visible part of the EM spectrum obtained through a Bhang meter. This graph is key to figuring out what happens. We shall aid Ria as we are good comrades. Relevant information that she overheard and knows. A nuclear bomb consists of a core of fissile material. To make nuclear fission occur, this core is made to implode. When this core implodes, it achieves what is known as criticality and nuclear fission occurs. A superheated ball of plasma is formed in the core, which is at a temperature of tens of millions of kelvins, 20s of millions of Fahrenheit for the Americans. The Bremsstrahlung effect is electromagnetic radiation produced when high-speed charged particles, typically electrons, are decelerated and deflected by the electric or magnetic field of an atomic nucleus. As the electron slows down, its lost kinetic energy is converted into a photon, creating a continuous spectrum of X-rays. The following is the EM absorption spectrum of the Earth's atmosphere. Compton scattering is the inelastic scattering of a high-energy photon, X-ray or gamma ray, by a charged particle, typically a loosely bound electron, resulting in a decrease in the photon's energy and an increase in its wavelength. Question 1. Explain why the first peak in luminosity is formed with an appropriate physical mechanism. Question 2. Why is there an initial dip after the first peak? Explain with appropriate physical mechanisms. Question 3. Explain the increase in intensity afterward with appropriate physical mechanisms. Ria also steals the access codes for Area 52 and enters to witness a nuclear test. The specific test was a low altitude test. There was a robust against EM fields device measuring electromagnetic fields, which measured an electromagnetic pulse, predominantly radio waves, passed through after the second flash. Ria knows that the dipole moment of the system of charges is defined as P equals to summation of Qi Ri, where the system consists of a charge Qi whose position vectors from the origin are Ri. She also knows that a time-varying dipole moment produces electromagnetic pulses. Question 4. Given the above information, explain the physical mechanism behind the generation of the observed EM pulse. Ria returns to the Soviets with her findings and is rewarded with a rather large bottle of vodka. Based on her observations, the Soviet military decides to conduct 2 tests in interstellar space. Unfortunately, one of the launches failed and the bomb exploded in the high atmosphere, the closest point to the Earth with no appreciable air pressure, while the other bomb successfully exploded in interstellar space. Please note that the Soviets sent the same robust devices as before with the bombs to perform measurements. Question 5. What differences would you expect to see between the 2 bombs and the low altitude test with regards to the 2 flashes and the EM pulse? Explain why you see those differences. Assumptions. When Earth's atmosphere is heated to a plasma, it becomes highly effective at scattering optical wavelengths of the EM spectrum. Participants, do you have any doubts? No doubts. Teams, your 15-minute for thinking start now.
Question number 3, you have referred increase in intensity. Does that mean increase in luminosity?
Yes,
Figure?
yes, yes.
Okay.
Ten minutes remaining. 5 minutes remaining. One minute remaining. Thirty seconds remaining. Time's up. IISc, you have 5 minutes to present your answer. Your
Hello.
time starts now.
For question 1, that's when the nuclear bomb explodes, it releases a wide range of radiation, right? Yes, sir. It releases a wide range of radiation, and well, that causes the first peak in luminosity, because like among the radiation there should also be the radiation in the visible spectrum. So that produces the first peak, but then there is a sudden drop, and that is because when a nuclear bomb explodes, it heats up the atmosphere around it. So this region becomes more like a plasma. It behaves more, starts to behave more like a plasma, and that scatters away. And as it says in the assumption, that scatters away the visible light, and so we suddenly see a drop in luminosity. So that's for question. That explains the initial dip in question 2, and to explain the intensity afterwards. The plasma can be assumed to be like made up of charged ions and stuff, and their interaction with the nuclei under breaking, like due to the Brahms-Starling effects, produces X-rays, which again interact with other charges, other electrons in the plasma due to the Compton scattering, which increases the wavelength from X-rays to visible, which leads, and those effectively escape the plasma and lead to the second peak, and that is roughly on the time where the plasma cools down as well.
For the fourth part, my proposed mechanism is something like this. Due to scattering by photon on the electrons, since the scattering reduces the energy of the photon, it will increase the energy of the charged particle. So it will cause displacement. Now in the real space, the displacement will be such that the orientation will be disturbed, due to which there will be a change in dipole moment. And since it is irregular, it is also time varying. The time varying, as we know, the time varying dipole is going to produce an electromagnetic wave. So this is a general proposed mechanism behind the generation of the absorbed EM pulse, as we get.
For question 5, since when both the explosions, let's look at the explosion that happens completely in vacuum. That is the second one. As there is no air, there is no plasma generated, and so we expect to see only a singular pulse. And because there is no plasma, we also don't like a singular pulse of light, as in singular flash. No, and you also, since there is no plasma, we also expect a singular pulse. What do we expect?
Okay. So for question number 5, for both the bomb that blasted in the high altitude and in the vacuum, we expect only there to be a singular flash in the EM, in the visible light. That is because the whole plasma that was being formed will not be able to form. Yeah.
And no.
Using radio astronomy. So, firstly, like I'll start with 4 a bit. The mechanism, there's some mechanism by which dipoles are being created and they're vibrating, but that will produce light across the entire wavelength, across a lot of wavelengths, but only the radio waves from around 10 millimeter to between 1 and 100 meter will be able to survive, because the absorptivity of the atmosphere is low in that region.
1 minute remaining.
And just one clarification regarding the 2 bombs. For the bomb that takes place in the high atmosphere, if the range of the heating manages to reach areas where there is a significant amount of atmosphere, then those might get converted to plasma. And so for certain observers, they might witness 2 flashes, but as they move slowly outside the range, the 2 peaks start to converge to a singular peak. The second
30
peak starts to die
seconds
out.
remaining. Time's up. IIT Madras, you have 3 minutes to present your answer. Your time starts now.
Our arguments mostly follow the same arguments for question 1 to 3. For the fourth one, I want to add that maybe due to the loosely bound electrons, so there may, the dipole moment of there is a change in the dipole moment, and due to time varying dipole moment, we have electromagnetic pulses being produced, and they are basically the reason behind the generation of EM waves. And मुझे कुछ और बोलना है? Fourth बोला
Yeah, so in the in the first three questions, like the first increase in the luminosity, it happens due to like the nuclear fission. So whatever energy is released, so it increases the luminosity, and the dip happens because as the heat is released, so it is captured by the atmosphere and it's heated to a like, as there's one assumption like the Earth's atmosphere is heated to a plasma, and it becomes like effective for scattering the like the the wavelengths. So by which like results in which results in the dip, and like the further increasing of this luminosity happens due to the Compton scattering, where this high energy photon is the energy gets decreased, and which increases the wavelength, and this wavelength increases from the X-ray produced by the Bremsstrahlungs effect to the visible region, which gets absorbed, which don't gets absorbed, and it's shown in the luminosity.
Since this is the plot for the visible region only, the continuous flow of X-rays get their wavelength increased and come under the visible spectrum. That's why we experience
1
this
minute
increase.
remaining.
And in the fifth question, this will not happen because the atmosphere will absorb the X-rays. In the fifth question, this will not happen because the X-ray will, because the atmosphere will absorb the X-ray. So we will only see one flash.
So yeah, there will be only one flash in fifth question.
There are three things to compare in the
30
fifth question.
seconds. Time's up. IISER Bhopal, you have 3 minutes to present your answer.
For question 1,
2 minutes.
What happens is this is some sort of the graph which we get. So the first peak is due to the visible light or the visible light radiation. Why does this because when the nuclear bomb explodes, it releases radiation. That is due to there is a first peak. Why is there is a dip? The dip here is there is because near the nuclear bomb temperature increases. We know since temperature increases by Wien's displacement law, lambda decreases. Since lambda decreases, therefore the rays which are released are no longer visible, but are more towards the UV away from the visible spectrum. Therefore, since this reader is only measuring the visible part, therefore the reading decreases. Then the second, now why is there is a sudden increase? This increase I believe is due to the Compton effect. Why this belief is due to the Compton effect? Because after a specific time, the
1 minute remaining.
electrons, they spread and this increases, this scatter and all. This increases the lambda, again this increases the wavelength, and therefore it again reaches the visible path, and therefore this gives us visible path again.
For the fifth question, when the bomb explodes in the interstellar space, we will and also when it will burst in the Earth's atmosphere only, we will see the
30
luminosity similar to as the graph given below. We will see uh, in the atmosphere one, the luminosity will be less because the atmosphere is absorbing the visible rays, and in the outer space one we will have the luminosity more for the visible light, and for the after pulse of the radio waves we will have use radio waves pulse for the outer space and very less for the
Time's up. IIT Delhi, you have 2 minutes to present your answer. Your time starts now.
Yeah, so we agree with IISC's explanation of the first peak, but we do not agree with their explanation of the subsequent dip and the second peak. Notice the time scales. The first peak occurs in the 10 micro to 1 millisecond region. We claim that this is because of the movement of the photons, in the sense that due to Compton scattering, like you had the nuclear implosion, right? A lot of photons were released. Now they are getting Compton scattered when they interact with the electrons. So they're dislocating that electron. So that electron is going in somewhere, and the deflected light is of higher wavelength, which is in the visible region, which is getting visible. Now these deflected electrons, these are what are causing the second portion when they are interacting with the other atoms which are within the nuclear bomb itself. And this dip is being caused because all of your Compton-related light production already happened by, say, this point, and then the electron has not yet reached and started the Bremsstrahlung effect until this point.
1 minute.
Which is why in between there is a dip. The EM pulse instead is created when these electrons are further, like they're still going out, and the air, the air is getting ionized, and that ionized air due to a dipole effect creates the.
Yes, so basically, as per this logic, since the first one is by Compton and the second pulse is due to the second flash is due to the Bremsstrahlung, flash 1, flash 2 both will be there in space as well as air, and the pulse is due to the plasma created by the heating of the
30
surrounding
seconds.
air, and in the plasma there will be electrons, and the change in the dipole moment will cause the pulse, and hence in the case of air there will be pulse, in the case of space there will be no pulse.
So near to air, because the violence of the nuclear bomb or its magnitude is so much that even if there is less density of air and the air pressure is not that significant, it will still cause change in dipole moment.
Time's up. Judges, any questions?
Yeah, I just wanted to ask IISc. So in question 4, you used phrase like charged particle.
Yeah.
Charged particle displacement.
Basically, see, in the scattering forces, the photon energy is going to decrease, but total energy is not going to change for the photon plus the charged particle system. So the charged particles energy must increase. Now, my claim is that since the charged particles energy is increased, it's going to move, its motion is going to be more violent than what is usual is, which can cause a change because it is it is also a charged particle. So it can cause a dipole movement due to its motion. Especially due to its change in motion, it will be a changing dipole moment, especially varying with time.
No, like we just mean that the moving particles will collide. The moving charge particles will collide with molecules, and due to that sort of reaction that is happening, there could be, and then it will be ejected again. There might be a dipole moment that is instantaneously formed.
But
And
which direction?
We don't know about that particular direction, but whatever that direction it will be changing. It will be varying with time. That is why the EM pulse is forming.
So are you saying that there are two parts to this? One is radiation due to the accelerated electron, and the other is because it is exciting something in the molecules? Because when you say collide with the molecule, what are you? I mean, what
Mainly, it's
what
the
effect does it have on the radiation?
accelerated one. That's the main factor.
So IISc, you for your first answer mentioned that the dip happens when the plasma forms and that stops the light from passing through. And then for the second increase, you argue that the X-rays turn to visible through Compton and then they escape the plasma. How are you arguing it? Like both the arguments, can you just connect?
The point is that the plasma is for essentially we're arguing that the plasma has essentially ended in the time period where this is happening. That is our main argument. So firstly, the plasma is formed due to which the electrons are scattered and essentially the net output of the nuclear reaction, it diminishes and it sort of ends, and then the electrons are still there. Those electrons are due to the like the Bremsstrahlung effect, like they're giving X-rays. By then the plasma settle. That is the point. So, but the EM waves have already been, sorry, the visible light has already been scattered, and then the Compton effect will occur and it will give us light. That is the sequence, sort of.
Okay, this is a follow-up question, but how does the plasma form?
It is just ionized particles and charged particles that are moving.
The as it says, the nuclear bomb. Okay. It's given in the question like irrelevant information that.
You guys
What?
have said that there is you said that it speeds up the atmosphere and makes another plasma. That plasma, how is that plasma formed?
No, we never said something like that. We just said that the plasma that was formed in the nuclear bomb, that thing is expanding.
Okay,
And that is
just
the-
tell me, how does the plasma form? What is the mechanism that creates the plasma?
It is essentially, as far as I understand, you're heating up the substance, the air. So the air essentially breaks down, and the electrons and the charge essentially electrons are ejected, and then particles are further ionized. And because of the high temperature, the state at which the matter is, it is called the plasma.
I had a question for IIT Delhi. Hmm, you said that the dip is because Bremsstrahlung is not yet initiated, something to that effect, right? Can you please go through that argument once again?
So our argument is that like we know photons travel significantly faster than electrons by some order of magnitude difference, and we notice that there is like since it's a log plot, there is a time difference between the first and second peak. So the first peak is produced due to the Compton scattering, which is the photons interacting with the electrons, and then when the electrons themselves start moving, because after Compton they are delocalized, so their motion when they interact with some other atoms nucleus and they slow down, that also releases a second wave of light, and that wave of light will be significantly later because the electron has to physically move for that to be produced. That is Bremsstrahlung.
I think one more thing, it is also important to realize that the dip in the question is still one order of magnitude more than the normal luminosity. So it's not so much as one effect stopping and then the other starting, but one slowing down and the other picking up speed.
IIT Madras, you guys argued that having loosely bound electrons changes P. How are you arguing that?
Oh, so like adding to that some mechanism of motion to changing to having a time varying dipole, we just added an hypothesis that maybe due to loosely bound electrons there may be a net change in charge, and due to that the net dipole moment is changing, and that is the reason for the dipole being vary. So that's just an argument for the EM pulse.
IISER Bhopal, you guys have argued that as the temperature increases, by Wien's displacement wavelength decreases, and then from Compton we get more visible light being produced. That explains the second peak, right? So even after the second peak, we see that there's a downward slope. Does your mechanism account for that?
Still the temperature is still very high for a very short period of time. Therefore, still fill due to Wien's displacement law again. The the spectrum moves away from the visible spectrum. Therefore, again there is a dip at that point.
Right. So as the Compton is like, what stops the Compton in that case?
The sudden increase in the temperature will be for a short period of time. So the temperature will peak very much and then decrease, like decrease drastically, not very much, but decrease drastically. So the effect will not overtake to lower the wavelengths.
Sorry, I didn't get this. You are saying it falls drastically, but not very much. I mean,
Means if the temperature goes to, for an example, 10,000 Kelvin, so it reduces to around maybe 1000 or 2000 Kelvin in a very short period of time. If the initial temperature was 500, then it reduces to 2000 or 3000 Kelvin. 500 to 10,000 or 15,000, like very high temperature, then it reduces to short, less temperature, like 2000, 3000 Kelvin. And this increase and decrease takes place for a very short period of time.
I have one final question. Just let me take some notes. For your question 5, what are the cases that you've drawn?
The above one is for the outer space and the lower one is for the atmosphere. The outer space for the reading in both the flashes and the afterward pulse, there won't be that much disturbance. But in the atmosphere one, the atmosphere is absorbing the visible lights, also the radio waves. So we will get a lower reading for both.
That is the high altitude or low altitude atmosphere depths?
High altitude. Like the bomb exploded in the high altitude it was given.
So I now request a member of the question making team to explain the answer. A question making team.
Sarah? Okay, so in the first part of the question, we explain how a fission bomb works. So there's a bomb casing. This is more of a fish, but you know. Okay, there is a core in here. This has your uranium, and you have implosion charges all around the bomb like this. So to make this bomb go, you explode all of these charges at once, compress the uranium, and then it will go supercritical and become the superheated plasma that we told you about. Now this superheated plasma is enclosed completely inside the bomb. So you cannot see this plasma. It is completely enclosed in the bomb. Now the second part of the question tells you about Bremsstrahlung effect. This plasma has a lot of very, very high speed moving ions. These ions will do Bremsstrahlung effect and release a lot of X-rays. So this plasma ball becomes a very, very sharp X-ray source. So you have X-rays coming out of here. The next part of the question, you see atmosphere. We've given you what is absorbed, what is not absorbed, and Compton scattering. So X-rays are absorbed by the atmosphere through Compton scattering, which heats up the air, forms a plasma ball around this weapon, and this plasma basically, you have a plasma ball outside the weapon. The light released by this plasma ball, which is given in our assumption, that's what the assumption means, that is your first peak. Now, this is a plasma ball. Plasma ball is very, very hot. So it also does Bremsstrahlung and releases more X-rays, and there's more Compton scattering. So the plasma ball slowly begins to expand. And as it expands, it loses energy, so it slightly cools, and the luminosity goes down. Although this is a log-log graph, as you guys have noticed, so the luminosity decrease has to be very, very sharp. So then there is something else governing this. So inside this plasma ball also begins to expand because there is just far too much energy here. Okay, so this plasma ball will expand, and as it does expand, the charge density decreases. Because of the decreasing charge density, your Bremsstrahlung reduces and eventually just stops. So your source of X-rays to your outer plasma ball stops. And because of this thing begins to cool and you have a dip. That is your proper dip. Now, what about the second peak? Now, when you think of a nuclear bomb, the biggest thing is the explosion, the shock wave. And that's exactly what causes the second peak. So this ball expands, it creates a shock wave destroys this plasma ball, keeps going outward, compresses the atmosphere, heats the atmosphere up, and you have basically black body radiation, and that gives you a second peak. Now we have to deal with the electromagnetic pulse. So we had an outer plasma ball here, we have a bunch of other charged particles here. So the charged particles, which are your electrons, the electrons are your negative charge carriers, and ions are your positive charge carriers. Now, just by simple logic, if you have a force, the same force applied to these two, the electrons are going to go farther because drag and whatnot. So the electrons are going to propagate farther than your positively charged ions. So what you get is, say your bomb exploded here, your electrons will go till here, and your ions will go till here. Now, you will get, and this gives you a charge separation and dipole. Now you may notice this is exactly symmetric. So outside this region, you will not notice any electromagnetic field. So you have to generate an asymmetry. How do you generate an asymmetry? At a low altitude, the air below is thicker than the air above. So the electrons will travel more above than below. So the explosion is actually not like this. It is something of this sort. And so there's a net dipole moment upward, which gives you your electric field. Now, in question number 5, we've given you 2 more extra cases. This is a low altitude test. So in a high altitude test, you will be high up in the atmosphere, and now the air pressure is not a factor. However, the Earth's magnetic field very much does come into play. So the Earth's magnetic field will accelerate your charged particles in a certain way. That gives you your asymmetry, and you still see an electromagnetic pulse. In interstellar space, it's a perfectly symmetrical explosion, so no pulse. And now talking about the flash, which is also something we asked. The flash here was caused by effects of the atmosphere. There is no atmosphere in either of these cases, but this is still a nuclear bomb, so eventually it will produce some light, so you'll have one flash in both cases. Electromagnetic pulse here, no electromagnetic pulse here, double flash, electromagnetic pulse. That's it. Thank you.
Hello. Hello. Okay, so we have IIT Madras. You have two options: happy, happy, joy, joy, or rolling in the deep.
Happy, happy, joy, joy.
All right. Happy, happy, joy, joy. Snejata, following the advice of her therapist, decides to put her happy helmet on and play with a large single domain crystal of ammonite. She illuminates the crystal with a coherent light beam of a specific wavelength, lambda naught, passed through a double slit setup as shown in figure 1. I hope I'm audible. This figure 1 depicts the setup. Question 1. Draw the variation of light intensity I inside the crystal along the crystal axis X marked in figure 1. The ammonite crystal contains Vipulon dopant atoms throughout which are fixed in place and cannot move. The Vipulon atom creates an effective set of energy levels in the band gap. The energy levels of the crystal are shown in figure 2. Question 2. Given this information, show how the negative charge density rho minus, where rho minus is the mobile electron density, and the positive charge density rho plus, where rho plus is the excited ion density, vary along x relative to I, first at time t0, right after the crystal is illuminated, and then at time t1, once Srijata has waited long enough for the distribution to stabilize. Explain, with appropriate physical mechanisms and processes, why the density stabilizes to the distribution you have come up with. Use a set of axes resembling figure 3 to answer this question. Figure 3 for reference. On subjecting the material to an electric field E, she finds that the polarization P of the material changes with E as shown in figure 4. Question 3. Assume that the material's refractive index is affected by the presence of the local electric field. Change in refractive index delta eta is proportional to the electric field. Then plot how the refractive index eta varies along x at a fixed depth from the crystal surface when the light is shining across the crystal in the setup. Question 4. Srijita now turns off the beams of light. Draw the negative charge density rho minus and positive charge density rho plus along x right after she does this, T2, and long time after she does this, T3. What is the plot of a refractive index at T3? Assumptions. 1. Electron-Vipulon recombination time is very large. Do the teams have any questions? Okay,
can you explain the assumption, what does electron recombination time means?
So when the electrons get excited from the Vipulon, they can recombine with the Vipulon defects. That time we can consider to be very long. Compared to the, we have mentioned a few time scales here, so say T1, T2, T3 compared to those times.
Okay, your thinking time starts now. You have 15 minutes.
At what point are we assuming x to be 0? Excuse me.
Question making team.
Excuse me. At what point are we assuming x to be 0?
What x?
Uh,
The arbitrary origin. You can
Arbitrary.
choose that for your, like, you choose it at the end of the crystal. Why not?
Okay.
Ten minutes. 5 minutes.
Yes. Yes.
One minute. Thirty seconds. You have ID Madras, you have 5 minutes to present. Your time starts now.
Yeah, so in the first question, एक सेकंड ये बनाना है बनाता हूँ तू जरा वो वेवलेंथ्स बना दे तो मैं बनाता हूँ जब like yeah, so in the first question, as theta is small, so we can just write like for for the proximity of from the center, we can just write theta as x by r, and seeing the path difference for the for the light reaching to this point, we can get the path difference as uh, this will also be theta, so we'll get the path difference as d sine theta. So when this d sine theta term uh, upon this lambda, this is yeah, so when this d sine theta term upon r becomes where theta can be get d as n lambda yeah, so you get the maxima at the positions which correspond to n pi difference and lambda difference. So you get this kind of a curve for intensity, and calculating the intensity formula, we get suppose we have I naught intensity from this slit, so we get the intensity as 4 I naught sine square theta by 2. This was the first question.
For the second question, we have first at time t naught the crystals being illuminated, and since at the maximas we have intensity of light more, and the energy is energy of a single photon will be hc by lambda naught, which is exactly equal to the gap required for the electron to escape to the conduction band. After the electron escapes to the conduction band, it is basically moving on the crystal surface. So first we have Wippulan atoms uniformly distributed across the crystal. So the amount, the positive charge density will stay uniform with respect to x. But the electron, after the first illumination, some of the electrons at the maxima will go to the conduction band. So just after the illumination of light, we will have the graph of lambda minus following a similar trend to the intensity graph. So then after a very long time, the electron move across the surface, and then they will be distributed. So the lambda minus graph will be similar to the lambda plus graph after a long time. For switching off, when I switch off, then my condition will be similar to the T1 case. And after a long time, since we have an assumption that the electron Wippulan recombination time is very large, so the electrons will then combine with their atoms, which are yet then uniformly distributed. So after a long time also, we will follow a similar graph.
Yeah, so yeah, so we get
30 seconds.
yeah, so as we reach to the ends of this crystal, we get higher polarization. So as the polarization increases, the electric field is also increasing, which will in turn increase the refractive index of the
expected.
Time's up. IISER Bhopal, you have 3 minutes to present. Your time starts now.
For one case, inside the illuminating crystal. So this crystal will just act like a screen of a double slit experiment just after illuminating the system. So it will form the simple double slit experiment curve. So this curve will be formed. This intensity curve will be formed. Uh, in the third question.
For the second question, then show how the negative charge density rho minus will for the t naught time when she illuminates the crystal for the first time, for where the enough energy SCY lambda naught reaches the electrons, yeah,
1 minute.
comes to the conduction band upper side, and where the energy is insufficient, the electron doesn't come to upper side. So the density charge density, negative charge density will be like this. And for the t1 time, for long period of time, after long period of time, the electron will spread and the energy will spread, and like since we have the assumption recombination time is very large, so the density
30
will be
seconds.
spread throughout, and the positive charge will be similar, because as the electron bounces off, it creates both the positive negative charge density and positive charge density.
For the third part, for the third part, the refractive index will vary something.
IISER Bhopal, your time is up. Ideally, you have 2 minutes to present. Your time starts now.
So unlike what IIT Madras and IISER Bhopal has done, what we have is a double slit, not a single slit. So our formula will be, our graph will be different. It will be roughly same intensities. The intensity here we have taken x equal to 0 to be the center point of the slab, and yeah, and as per that, this will be our intensity plot versus x. He's labeling it. Now, as for rho plus and rho minus, yeah. So at T naught, the Vipulon has just released the electrons. So the rho plus, the at points where the intensity is more, the rho plus will be more, and rho minus will also be more. It will be the same as the intensity graph. And after time t1, basically at the points where the light is here, the electrons will, and the positive and negative charges will redistribute because of a combined effect of the rho plus. Rho plus won't change with time because these are the position of holes. The electrons are the only ones that will redistribute. This is rho plus, this is rho minus. This is the plot of rho versus x. Yeah. So like at these points of the intensities, here
30 seconds.
the electric field of the light will tend to push the electron to the point of minima. This will form the potential energy minima, and this will be our graph at t equal to t1. All the electrons will tend to go to the minima of the intensities.
For the third question, we can just find the relation between the local electric field and simultaneously.
Ideally, your time is up. IISc, you have 2 minutes to present. Your time starts now.
So the first question, the pattern which we are going to observe will be the interference pattern due to the double slit, the Young's double slit experiment. But the path difference that we will be observing is, first of all, it is going to be d sine theta due to, of course, the slit difference, plus there will be some d naught due to the bending in the crystal, because we are considering inside the crystal. So that is what is going to be in our first part. For our third part, if we look at the diagram carefully for polarization versus electric field, we know that if electric field change will impact the change in the dipole moment. Now the polarization can be written in terms of dipole moment as dipole vector plus a constant k naught, where k naught is directly proportional to the permeability. Since my refractive index for any material is just 1 by under root of mu naught eta naught, the change in eta naught is the reason for change in n. Now for the eta naught explained, you can see the curve that the increase in electric field is not causing a direct increase in the polarization. Rather, it is the rate of increase is actually decreasing, and when the and we will move back the electric field, it actually decreases. So my claim is, when you increase eta naught, increase the electric field and decrease it to 0, my eta naught is going to decrease. So my neta, the refractive index, is going to increase, and vice versa.
30 seconds.
So along the x, the wave is going to be like this.
I'm essentially adding on to the IIT Delhi's graph. They are right in saying that the intensities will be approximately equal for part 2. But after that, I think the graph will even out with time because of the recombination as mentioned by IIT Madras. So it will even out. So you'll get the first graph will be the same.
I see your time is up. Judges, do you have any questions for the teams?
I have a question for IISc and for IISER Bhopal. So for IISER Bhopal, I want to understand what those, sort of square wave kind of pattern is.
When the crystal receives the light for
No, you're plotting rho minus or rho plus. I can't see what that is.
that is rho minus for
Huh.
negative charge density,
Okay.
and rho plus will be similar in the
So why is rho minus a box?
like the parts where the crystal is not receiving enough energy, the electron won't come to conduction band.
Okay. IISc, my question is, you said polarization is proportional to what? I mean, P is equal to K times P. What does that mean?
I mean, there's basically our observation was that the polarization depends on the dipole moment and some factors, which was the permeability. That was my claim actually. It was it was proportional to a constant which depends on the permeability of the vacuum. Means not a vacuum, rather the permeability of the medium, rather.
Okay. Okay. And for IIT Madras, I wanted to understand what that separation of charges along the rectangular slab is.
So like we have localized electric fields originated because
No, but is that rectangle the entire crystal or what?
no, the electrons are at the surfaces and positive charges are the energy crystals. Like the Wipulon atoms are inside the crystal, so the positive we represented as the Wipulon atom positive charges, and the negative are the surface charges. So the top one is the surface of the crystal.
Okay.
IISc, when drawing the graph for the refractive index variation, you mentioned something about the proportionality. What would that be? Can you please repeat that?
Basically, for the change, what proportionality first have you asked?
So you were arguing something about epsilon naught increasing or decreasing. I don't remember exactly what it was.
Epsilon, actually, the refractive relative permeability of the medium, that's decreasing, because for an electric field, if you increase the electric field, the dipole moment is going to increase as per the electric field. But from the curve, it's like a hysteresis curve where the polarization is not increasing as linearly. That is the and that might be due to the decrease in the relative permeability. And as you can see, if I decrease my electric field back to zero, the polarization actually has gone down. So definitely there is a change in the permeability medium, decrease. Since my neta, which we know is 1 by mu eta, and eta is decreasing, my my neta is going to increase. And since my electric field is going to vary like this, oscillating, that's why I draw some sinusoidal graph on the x-axis, because electric field wave is sinusoidal. That's why the graph is like that.
Okay, and for the pink graph to the right of that, what is that written on the left of T naught?
Can you repeat what?
It is written to the left of T naught in pink.
No, like that is.
Okay, okay. I just missed that question too.
IIT Madras, I think you said something like lambda minus and lambda plus are same at long times. What was the exact statement you made?
Like for question number 4, we were saying that after long time the electron Vipulon will recombine, but since the electrons have like the crystal has become conductive, the electrons will be spread out.
But what was the information given to you about recombination?
That the electron Vipulon recombination time is very large.
Okay, and
the Vipulons are uniformly spread.
And this is question
4.
But I thought in question 4 you are asked the plot of refractive index at T3. Am I missing something?
Sorry, like the refractive index plot we have not drawn. We have answered the part A.
So, okay. But then it was at T2.
Yeah, T2.
Okay, and T3, T2 and T3.
Yeah.
But I think you were given that the recombination time is larger than all the time scales in the problem, right?
Yes.
So how did your things recombine?
So like it is given that T3 is after a very long time, so I thought that recombination would have occurred.
I think you should have listened carefully to the statement about recombination time. There was a clarification asked, and he said it's greater than T0, T1, T2, T3, all. The recombination time is greater than all the T is given in the problem.
T minus C, for your refractive index graph, what is the frequency of the oscillation compared to the frequency of your intensity distribution?
It should be same as the, or very close to the electric field frequency.
And is there any phase difference between the two? Okay.
There should not be phase difference, because as the electric field is increasing, the refractive index is also increasing, and they are achieving the peaks at the same rate.
Okay, thank you.
All right. I invite one of the members of the question making team to come up and explain the solution.
For question 1, we just wanted you to draw a simple interference pattern. Since we are considering interference and not diffraction, the amplitude should be roughly the same. And then for question 2, do we have some duster? For question 2, what we expect is this. So we have the axes. Here is the intensity. Here is rho along x and x. So along the intensities, wherever more light is there, we get more electrons getting excited. So we get more mobile electrons and we get more excited charges, so excited defects. Hence, this is the form of rho minus, this is rho plus. If you drew the modulus of it, that also works. The net charge in this case is still 0 throughout the crystal. Then this is at time t0, and at time t1, since there is an abundance of mobile electrons in the maximas of the interference bands, in the minimas there is a lack of them, so there will be some diffusion of the electrons. But since you have excited defects here, they will mostly be concentrated around this place itself. So what you will see is kind of a damped sine wave with the electrons spread out a bit, but still centered around the rho plus where the intensity maxima are, and the net charge density, can I get another color? The net charge density turns out to be positive at the interference maximas and negative at the interference minimas. This is the net charge density that turns out to be. So we can then draw this picture of the crystal where we get positive, negative, positive, negative, and in between them we get electric fields. So then for question 3, when we are talking about the refractive index, we look at the electric fields that these generate. These electric fields induce a polarization within the crystal, and that polarization gives you the local electric field according to which your refractive index should vary. So we get positive deviation here, negative deviation here, positive here, negative here. The delimiting lines match to the maximas and minimas. Just a note, but this variation in refractive index is only along the x-axis. So this is only for light traveling along x-axis. Along the propagation of the interference pattern, for example, you won't get a variation in the refractive index. And after the light is switched off, immediately there is no change. After some time, there will be some recombination, not much. There will be some recombination, but since the electric field is weakening, you will still get some polarization because of the hysteresis. And even when it goes to very, very long time, so suppose you do reach the recombination time scales and the electric field is 0, because of the hysteresis, you expect to see some non-zero polarization. So the interference pattern is kind of encoded onto the crystal because of these positive, negative structures that form. And the refractive index variation will only weaken in amplitude, but it will still be there due to the same reasons. Thank you.
Okay, just give me a minute. IISER Bhopal, you have one option left, rolling in the deep. Santa Sharanno has given up on humanity. He decides to hunt for coal. Therefore, he has pivoted to working on a method to find defects on the surface of a material using sound waves. Santa Sharanno has a very large block of homogeneous elastic material, nilch. A very thin slice of this material along the xz plane is taken, which can be considered as extending to infinity along the x direction and along positive z direction from z equals 0 onwards. Here is the figure for reference. Above the slice is a vacuum. Note that for a surface boundary which has a vacuum on one side, the following relation holds due to the fact that the stress must vanish from a boundary against a vacuum. The relation being del uz by del x plus del ux by del z is equal to 0, where uz is the displacement of the medium particles along the z direction and ux is the displacement of the medium particles along the x direction. To better understand surface phenomena, Santa Sharanno considers a simple set of horizontal displacements. Finite energy is put into the system, applied on the surface as shown in figure 2. And the horizontal displacements between A and B change as shown in figure 2, 0 everywhere else. Ignore gravity and thermal effects while answering all the questions. Be very careful with the signs and directions. Question 1. Draw the graph of del uz by del x and uz as a function of x. Question 2. Compare the deformed and undeformed states of the material near the surface between points A and O and between points O and B. Draw a diagram for infinitesimal areas in the xz plane. Suggestion: consider the area to be a square. Now we apply displacement ux on the surface, which varies sinusoidally with x. Question 3. Draw the graph of uz and ux sinusoid as functions of x on the same graph. The sinusoid ux now starts moving to the right at a steady speed. Question 4. What motion and or deformation does an infinitesimal region of the material undergo? Draw diagrams for infinitesimal areas in xz plane. Suggestion: consider the area to be a square. Do you need any clarifications, teams? All right, your thinking time starts now. You have 15 minutes. 10 minutes. 5 minutes. One minute, 3 seconds. Twenty-nine seconds. And your time is up. IISER Bhopal, you have 5 minutes to present. Your time starts now.
For the third, draw the graph of ux and uz sinusoidal as function of x on the same graph. This one is the given graph of ux on the x, and this one is for the uz. For the second one, compare the deformed and undeformed states of the material near the surface between A and O, and between points O and A. As we have the graph of surface displacements from the A and O in the x direction, we have a positive displacement, and from the O and B, we have a negative displacement. When we have a positive deformation in the x direction in between A on A, since the upper surface is vacuum, so we can't have a stress. So in the z direction, it will balance out the surface displacement. So the displacement is causing a stress in the direction. It will balance out that stress to maintain the vacuum above the surface.
1 minute. Your time is up. IIT Delhi, you have 3 minutes to present. Your time starts now.
Yeah, so the basic model which we have used is that is that suppose this is the area, right, and this is A and B. Then consider this slice. Now, when we displace the surface, then this bends like a bar which is being displaced. So it becomes something like this. And in terms of if since we are asked to draw like a square, so this square will go to this kind of a shape, where essentially over here in the near the O region you are witnessing a compression, and this is like a rarefaction if we use the terminology of sound waves. Now, given that the UX is like this, now if we see this kind of a structure, then for the smaller values of x, there's a huge increase in the value of x, in the value of z. So our value of del u z by del x is very high initially, and then later on it's like almost constant. We're also given that it's a finite energy thing, right? So it can't extend for infinity. So that is why our del u z by del x decreases and almost falls to 0 as we go on. And correspondingly, del u x by del z, since it is the sum, it is the exact opposite. इसके बाद क्या है? शिवप्रदीप वाला draw हो रहा था ना? Now if we have to draw uz as a function of x, then uz versus x बनाया क्या कहीं पे? कोई uz versus x? ये तो del uz है. uz versus x कैसे बनता है? So again, plotting
1 minute.
z versus x exactly according to this. Bigger values when there is bigger x, because it is 0 at 0, and according to the derivative we have constructed uz to be of this shape.
Since we are applying a sinusoidal force, the newer graph formed will be similar to the initial graph where we consider a constant force. It will be changed such a way that it will
26 seconds.
simply overlap the one that was initially present. The newer UZ graph will be similar, will be just a product of our initial constant graph along with the sinusoidal graph.
Your time is up. IISc, you have 2 minutes to present. Your time starts now.
So from the equation, we can just say that ux as a function of this is something like umax, some sinusoidal function, pi by 2 x by x naught, where x naught is the maximal displacement from x for a to b and 0 elsewhere. And if we were to use the equation, we know that del u x by del x is equal to minus del u x by del z, which is the sinusoidal one, the umax cos of the term times del x by del z. Now if we study the graph of ux versus x very carefully, we will realize that as we move toward the b, the displacement is negative, so it is going to push more toward the center. So as I display, it's going to push here and it's going to maximize the push. So my displacement tendency of O is going to be more towards the upward region like this. Due to which my dx by dz or del x by del z I will call, which is going to be negative here along the positive direction and positive here along this. So this will be some sinusoidal function. Yeah, this is going to be sine of some function. So the overall function will be some umax sine 2 times whatever the factor is. So my graph for dz by dx, it is going to be something like sinusoidal essay. So it is going to be sinusoidal like this. And similarly, if I go integrate,
Yeah, this other end will won't be an exact
It would be like this.
Yeah.
It will be.
It won't be an exact sinusoid. It would actually fall off and go away.
It will be.
Second case when there are multiple.
Your time is up. IIT Madras, you also have 2 minutes to present. Your time starts now.
Okay, so for the first part, we have we have an equation of delta ux by del ux by del uz by del x plus del ux by del z equal to 0. A common observation is that uz goes along with z. Like if my del uz by del z will be z goes with okay, sir. Okay, so the displacement along the z uz will be directly proportional to z somewhat. So that won't be used later in this. But next we have to plot graph of uz as a function of x and del uz by del x as a function of x. So as we can see, this AOB region, we have a higher magnitude of ux near A and B, and that leads to a more push of particles near A and B. Near the center, we have push from both the sides. That's why here also we will have a higher magnitude of force. So the deformation at A, near A, O and B will be larger, and it will take a shape as this. Then for question number for question 3, we have sinusoidal graphs and multiple sinusoids along the x. That's why this graph will be just repeated in a similar fashion. This was not given as a sinusoidal graph, but this sine graph will have a perfect sinusoidal function for
30 seconds.
this. And question 4 has the ux moving with a steady speed, so the deformation will also move along, and as explained here, it will be shifted. So if we draw infinitesimally small squares and compare, then I can see a higher magnitude of forces here. ये मैं बता ही दिया था. Okay.
Time, and your time is up. Stop. Yeah. Judges, do you have any questions for the teams?
Yeah, who went first? IISER Sorry. Yeah, IISER Bhopal, right? Yeah. Where are you there? So, what is your answer to question 1? I did not quite understand. That graph which is shown, first graph, that is what was given, right? From A to B, that decreasing, that is the ux which was given?
Yeah, A to B1.
Yeah, please.
A to B1.
Yeah. So what is that a graph of? You haven't drawn the axis, so just tell me verbally.
UX.
Ux. Yeah, so that's what was given.
Yes.
Now you are asked to find del duz by dx.
Yes, sir.
And that's this?
That is for dux for by dz.
I can't hear you.
Dux by dx.
Dux by dx. I don't think you are asked dux by dx as far as I can read this. Huh? Yeah. On the board you written duz by dx. Which one is it?
It was written by mistake. duz by dx.
So what do you want to write? Say, please say clearly, loudly. At top of
Dux by dx.
dux by dx, but that's not the question, is it? It's not the question. But no, you're not answering me. Is it the question? You have the question as I have it also.
No, sir.
So what is the question?
For duz by dx.
Okay. And you've written that on the board, so I think you wanted to write the correct thing, but now can you just explain how you got this?
So it is for duz phi dx for the second graph, which is already given from A to B1. it is not for the duz by dx for the first figure which is given.
First figure. And
Okay, sir. It is for the graph given, yeah, A
yes,
to B1.
yes.
The graph I have drawn from A to B, the semicircular graph,
Yeah.
it's for duz by dx.
Okay.
Yeah.
Okay, fine. Let's leave it there. Also, IISc, I have a question. I think I saw a lot of dx by dz and dz by dx on the board. What do you mean by that? Or did I read it wrong?
The topmost is just an explanation. The second in the middle, that is duz by dx,
Oh.
del u by del x versus x.
Okay, okay.
And the last one is uz versus x.
duz versus dx. So do you have a graph of that? These graphs are not labeled, so I'm not able to remember.
The middle graph.
Yeah.
On the top left graph
Yeah.
is uz.
The topmost is nothing, that's the explanation. The middle graph is del uz by del x versus x.
Okay.
The bottommost graph is uz versus x.
I see. uz versus
UZ
x. Okay. Okay, thanks.
Team IISER Bhopal, when you answered the question, you mentioned something about displacement in z direction causing stress on the surface. Could you please elaborate?
For the figure 2 which is given, we have given a positive displacement in positive displacement from A to O and negative displacement from O to B. So I was telling that because we have a vacuum in the above surface, so the stress must vanish. So to nullify the stress, there will be a displacement in the z direction.
Positive or negative z direction?
For A to O it will be negative, and from O to B it will be positive.
Team IIT Delhi, in the graph you've drawn for question 1, can you please clarify the graph for uz? Can you please clarify where z equals to 0 is?
The graph is drawn as versus x, so like x is equal to 0 is at the peak.
Let's see your middle graph. Why do you argue that it will be asymmetric?
Can you repeat what you asked?
For your middle graph, why do you argue that it will be asymmetric?
It is kind of asymmetric because as you can see, the expression of del u by del x was umax cos of that function pi by 2x by x naught, but dx by dt. From the topmost figure, I just explained that since using the ux versus x curve, there is a pushing towards the origin O, which leads to the displacement of the O in the upward direction. So if you move from O to B, there is a negative slope, and if you move from O to A, there is a positive slope, and that is, and since the curve is more looking like a cosine type, so the del x by the del x by del z, yeah, the del x by del z is going to be that negative sinusoidal, reaching the mod value is max. So the del ux by del z is sine of 2 times that, will be, which will be 0 even at A and B and at the origin, and the peak will be somewhere. And beyond A and B, it's going to be just 0. And just by integrating del uz by del x with respect to x, I can get uz versus x.
Okay, thank you. IIT Delhi, if possible, please come up to the board and point out where your origin is. So z equals 0, x equals 0 on the bottom two graphs.
Yeah, so this is the graph of uz versus x. This is our x-axis, and our O is the origin, and question mein jo it was given A and B, these are those cutoff points. And same in this one, this is the, with respect to x, this is the uz versus x, origin A and B. Yeah, this is ux and this is uz. Ux, this is the in the sinusoidal wala part. Ux was given to be this sinusoid, and uz is with respect to that, this will be the qualitative graph.
And also, like, the del uz by del x graph is getting cut off at like this B and A, which we drew later. I'm not sure whether we will speak it or not, but we intend to cut it off over here.
For the bottom two graphs, please draw a line for uz equals 0. Those two are the lines.
Z equal to 0.
uz equal to 0. That is the point. And on the second graph, the one to the left of it.
This is our uz equal to 0. uz equal to 0. Here uz equal to 0. This is also uz equal to 0.
Okay, thank you.
I mean, just to clarify, were you asking have we specified whether this is for a single Z or not? Was that the question? Because it's also that, I mean, under the bent bar way in which we have characterized, even if you go at some other value of Z, there also the uz versus x variation will be similar, if not.
No, it's fine.
Team IIT Madras, in your answer for question 3, could you please say which is UX and which is UZ?
UX was given in the question itself. The UX versus X graph, and the bottom one is the UZ versus X graph. But the above one, that's UX versus X graph. Oh, that's for the question one. For question 3, question 3 then.
So IIT Madras, you guys, for question 1, the graph on the bottom, you guys had mentioned that even if the displacements given are not a sine curve, that will end up being a sine curve. No?
I said that the question didn't mention the first graph as sine curve, so the second graph will not be a sine curve. But since question 3 mentions a sine curve, the second.
I call a member of the question making team to come and explain the solution, please.
Okay, so you've been given the graph of del UX, of UX by X, and you've been told that finite energy is put into the system. So as they identified here, sort of bends like that a bit. Your magnitude of displacement dies down with depth. And so for region AO, del UX by del Z is negative, and for this region del UX by del Z is positive. So your graph for del UZ by del X will look something like this. If you just integrate this, you get the graph for UZ versus X, which is something like this. So this is UZ, this is UX. Now for question 2. Oh, sorry, my bad. This is X. Now for question 2, consider a square, a small, very small square from region AO. Oh, okay. So since the z-axis is in the question, it's given as pointing downwards, just reflect this. That. Now for this square, the displacement above this will be greater than the displacement below this, and it is in the positive z direction. And for the left side, UZ is less in magnitude than it is to the right. So you have something like this. In the end, you can break this down into something of this sort. And another rotational component. So you have translation plus rotation. So your area element sort of just does this. Similarly, for region OB, your area element will do something like this. Now question 3 follows from this. Question 3 is, you can simply just think of it as this extended along this, and so your UZ will just be another sinusoid, just pi by 2 radians out of phase from the first one. So if this is my UX, this is my UX, then the yellow curve will be my UZ. Now for question 4, you use similar arguments to question 2, and you get that for, okay, you should actually divide this into regions. So let's call this region A, let's call this region B, C, and D. And so if you repeat the same thing for the other two regions, because two of these regions, which are regions A and B, have been covered in question 1 and 2, you just repeat the same thing for regions C and D. You get very similar results. And in the end, when you move your sinusoidal wave along the positive x direction, an area in this place, suppose, now consider the regions are also moving along with your wave, will experience D followed by C followed by B and then followed by A. So in the end, if this is the direction of motion of my wave, the small area in the material will follow retrograde elliptical motion along with the appropriate rotations. Any questions? Yes. UZ minima at x equals to 0.
You have drawn UZ minima like ahead of.
No, in the diagram given in the question, UZ maxima will be at x equals to 0.
But like you have, like this is your. Yeah, so you have drawn like UZ equals 0 at x equal to 0.
This is not the exact same diagram I gave in the question. The question, hang on, my bad. There.
Okay, got it.
How did you get the first del UZ by del x?
Okay. Displacement dies down as you go deeper, which is along the positive z direction, which means del ux by del z is less than 0.
Yeah.
You use the condition given to you, you get del uz by del x is greater than 0.
Yeah.
Again, you repeat the same thing here.
So how do we get the shape? But we just got the sign.
See, even if you had gotten the shape qualitatively right, that it will be positive here and negative here, you still would have ended up with this answer. Does not have to be exactly a sign. Any other questions?
Okay, and with that we conclude the deep thought round for Physics Mimamsa 2026. Thank you so much for attending this round. Great job, guys. Mimamsa means we'll resume tomorrow morning with chemistry deep thought at 9:30 a.m. One final announcement, your team coordinators have ordered food for you, so just follow them. We will not let you starve. Good night.